So for the last part, in another transmission system, the probability of having at least 3 corrupted bytes during the transmission of 20 bytes is 0.85, and probably that a bit is corrupted during this transmission. Okay, so I'm going to use the same binomial distribution. So but now let k be the number of corrupted bytes out of 10 bits out of 8 bits. Okay, so that's the thing there. So finally, what we need to do now is essentially just write down k, and in this another transmission system, same thing. You put this as 8, and this would just be what do you call it? This would be p. Okay, so I'm gonna let the probability of a corrupted bit p. That is the first thing that I will need to do. Okay, so in this another transmission system, so once we're done, I get this as my just 1 byte. Okay, now you're saying that if you transfer 20 bytes of the and you have got there you go, you transfer 20 bytes. Okay, you having at least 3 bytes corrupted during the, there's so many confusing, but because of bits and bytes, right? So this is just a bits first. So you need to do the same thing as the previous one, meaning to calculate what are the chances where 1 byte is corrupted. So it's corrupted at least 2. So this case here, so chances probability of, so this case here, I'm gonna write it down. Probability of a corrupted bit using the new system would be same thing, pk. Pk, maybe I'll just write it down. So this one here is very important. Corrupted bit would be pk. At least 2, right? So this is 2 here. So same thing, which is 1 minus pk at most 1. Okay. Now the thing now is we are told that 20 bytes 0.85, right? Find probably that being the bit. So we need to find the b, find b. So we're told that having at least 3 corrupted bytes during a 20 bytes transmission would be 0.85. So there's another probability. So now let L be the number of corrupted bytes out of 20 bytes. Okay, this is the annoying part, because this is like inception, like you just keep convoluting, like just keep having more binomial within a binomial. So this will be 1 minus p k less than equals to 1. Okay, so there you go. So once this is done, find probably that the bit is corrupted during transmission. So we need to find p now. So probability of at least 3 corrupted by during transmission of 20 is 0. So this we could run a p l having at least 3 corrupted. So this is number 3 is given by 0.85. Okay, great job. So now we can write this down. Okay, so I need more space here, so I'm gonna just move it to the other side. Let me just put this the other side here. This is like, okay, so maybe I just craft it out. So in this case, you're gonna have 1 minus p l at most 2 equals to 0.85. Of course, I would like to bring the 0.85 to the other side. That's what I usually like to do. 1 minus 0.85, which is 0.15. So 0.15 minus PL at most 2 equals to 0. So I'm going to solve this by using the calculator here. So how do we solve it? First part is just need to put down this. So this is the probability here. Annoying, I know. Very, very annoying. It's so many things going on, right? So let me just key in calculator and show you how this is being done here. Okay. So this part here. First of all, we have got this one. So L, I need to key this in. So let's go to L. Then I'm gonna put this as 0.15, and I'm gonna put this as minus CDF. So this is normal binomial CDF. I put this as 20, and the P here, oh my goodness, is 1 minus. So you just put in this at most 1. So meaning to say distribution binomial CDF, and I'm gonna put this as 8 comma. I don't even know what's the syntax for this. Okay, I think we just do this first. Okay, so let me just quit to the main menu. So this is NP CDF. So NP and the number here. So the number here, this will be my X then. Then the number will be 8, and then this will be 1, right? So because I need this to be 1, this system here. Okay, so it is a lot of things to bring in. I know, a lot of moving parts. Just bear with me. This, I need to key this in. So I repeat, go to here, then I'll just put in this second distribution, normal CDF, because I'm keying this in. Normal CDF, then this will just be sorry, not normal CDF, binomial CDF. Then I'll just put this trials as 20, and this I'm gonna put this as 1 minus second distribution CDF again, but this time CDF will be 8 comma X comma, and putting this as 1. The X value here will be 2. Okay, so there you go. Paste it. Right, now you are solving for X, which is actually this what do you call it, the probability. So it's rightful to just put this as 1 and 1. So they zoom that the area there and find the answer. Okay, so this will be our answer here. It's quite tough. I think the problem with this question here is you have too many moving parts, which is like, oh, which part is which, and you really need to orientate in terms of like which binomial is which type binomial. I hope you understand what am I doing here, but if you don't understand, please let me know. So from GC, what we could calculate is 0.11. Okay, so using GC, P is given by 0.111. Okay, so there you go. Let me just write this down. Yeah. So this is how you do this question here proficiently. If you have any question or comments at all, please let us know. Keep practicing, and I'll see you in the next question.